Hello and welcome to the seventh lecture in our comprehensive course on AI, ML and DS. Now here we want to talk about these more examples of these filter methods. So we have done one example, select k best, where k is equal to 2 or k is equal to 5, that is according to the data set that will give two best features or five best features, right? Now here we want to use other three techniques which also fall under the filter method category only, that are statistics based methods. Filter method means one is correlation based feature selection, one is chi-square based feature selection, and one is mutual information based feature selection, right? So let us create same California data, but this time now I am taking an actual data, California data which we were taking, that was actual data, but we are taking now all the features. We are not limiting ourselves to three features as we were doing earlier for simplicity, because at that time concept was to be introduced. Now concept, we know we have done one example of filter method, one for wrapper and one for embedded. So now we just have to revise those, each of the method. Okay, so select k based we have done. Now we want to do other methods of filter based under filter based category. So let us import our data set, fetch California housing, and load that data set, and thereafter we split the data set into two parts. One is my feature matrix, where this time how I get my feature matrix, then from the entire data set I just drop the last column, that is this median house value column, right? So all other columns are kept. So this is itself my feature matrix. And similarly, from the entire data set, I select only one column. So this is the standard way of making X and Y. df is the given data frame to me, dot drop, and columns is equal to your response variable, and then Y is equal to df, and in bracket column name is equal to your response variable. Okay. So here this means take all columns except median house value, while this means take median house value, right? So this will take all columns except median house value, means all the features, while this will take response variable. Let me first clear the output of this cell and let us create. So this is converting the given data frame into the X and Y, these features. Okay. If I still want to make it clear, then I can add one cell here, and here I can write the rest of the target, rest of the lines of code in a different cell, and this is my df. This includes both features as well as response variable. Now I want to convert it into features and target. So therefore I drop this response variable and keep all rest of the things. That would become my feature matrix. This whole 20,639 rows and all these shaded columns, that will become feature matrix. Then I keep only this, and that will become my response vector. I'm calling vector because you can see that it has only one column, right? Okay. Then print the head of this and tail of this, each of those columns. So this is my feature matrix, this entire. Okay. And this is my response vector. Okay. So all these house prices, they are in multiples of this many $0.1 million, right? So 4.526 multiplied by this number 1 lakh you have to do. Now this, what we have done by code, how to do it by picture, that you should understand. We have already done it. This picture was already seen, but now you are getting its meaning more clearer, that this was my full data set. So this was my full data set, df. Okay. First of all, I am doing only this much part, that I am separating features, this green colored, which has multiple columns, and the target variable, which is having one column only. So this is my feature matrix, the green colored, and this is my target vector, the yellow colored. Now I do further that feature matrix will also be divided into 80% of the rows in the train. This is my X, features is X and target is Y, right? So X would be divided into X train and X test, 80% in X test train and 20% in X test. Similarly, Y target is also divided into Y train, 80% of the rows, and Y test, 20% of the rows. So from this you will get X train and X test, and from yellow you will get Y train and Y test. In the division is done horizontally, and 80-20% of the rows are there. So that is done here by this train test split, X train comma X test, Y train comma Y test is equal to train test split X and Y, feature matrix, target vector, test size equal to 0.3. This time not 80 and 20%, just for the sake of variation. This time 70% is in the train set and 30% is in the test set. You can take 80-20, you can take 85 and 25, any percentage. Okay, 90-10, but take sufficient number of data points in both train and test set. Here the number of rows are itself so large, 20,000 rows. Then I can have the luxury of dividing in any manner what I want. And then I just print what is my X train, this green, what is my Y train, this upper yellow, what is my X test, this lower green, and what is my y test, that is this yellow, right? Okay, so select and then print them. And suppose this much I take it to other cell, and this output also I am clearing at present, and we will check if things are working properly or not, right? So then you can see that this whole is my X train, this, okay. Similarly, Y train, that means this thing, okay. So that is having only one column. So this is my Y train, that is the price or median house value, okay. Similarly, now X test, so this whole is my X test, okay, this whole, and the remaining, that is my Y test. Here I can put one more separating boundary like this, so you can see clearly that this is Y test. Now what we do in machine learning, that you know that now whatever algorithm you will choose, that you will train that algorithm. That means that algorithm will be fed this data, and the algorithm will make several iterations on X train and Y train, and it will try to learn those some patterns from your data, training data, and then we will then whatever is created, that algorithm which has learned the pattern, that is itself called machine learning model. And once the machine learning model is created, then you have to do X test and Y test, right? On at that time, Y test you will not use, only X test you will use, and you will feed the trained model this data, X test data, this green, lower green, and you will predict Y test, okay, and whatever Y predicted, and then you will compare with actual values in the Y test, and how much difference is coming between Y predicted and Y test, that will give you the accuracy of your process, right? So this is the splitting only, and finally one step we do, that is just scaling, because the features are on different scale. So it would be nice if you do some kind of standard scaling or min-max scaling that we have already done. So we are importing a standard scalar object and scaling X test, X train, and X test. So you must remember that scaling is always done on green side. So that is response variable is not scaled, but only the target variable, they are scaled, and they are scaled separately. The training set and the testing set, they are scaled separately to prevent the leakage of the data. So you just scale it. Now so far we have not even started our discussion. Actually we were doing what? We were doing other filter based method, and this time I want to do these three methods. First I want to do is correlation based feature selection. Then second I want to do is chi-square based feature selection, and third I want to do is the third technique was, I think, chi-square based, and yeah, mutual information based feature selection, right? Then we will do three techniques for the wrapper methods, and then we will do two techniques I think for embedded method. But every time these data preparation steps will remain the same. So every time I will not explain what we are doing, because that we have already done now here, and I have explained with diagram and nicely, so you are now clear what we have done. So we have just made our data ready for any method. So whether you use filter or wrapper or any method, you have to make your data ready, and these many steps are required. Divide data into X and Y, then divide X into X train and X test, Y into Y train and Y test, train your model. So that training part is not done, but this much is already done. Okay, this Y portion we have not done. That depends upon method to method. Okay, in fact for these filter methods, no training would be required, because these are statistic based methods. So we know that they don't require what you call model training, right? So we just plot correlation matrix and heat map, and we try to see what is the correlation with the target variable. So that means these are various features, but I want to select only few of them. So I want to find what is its correlation with my target variable, which are the highest correlated features, right? So for that you can plot this kind of diagram, and you can see that the highest correlated features are these. And from this, if you want to just select one feature, which is the having maximum correlation with the target variable. What is your target variable? This median house value, right? So if you just want to select only one feature, then median house value, that would be the dependent on median income. So out of all these features, this and this, only median income is the most highly correlated. Then if you want to include, you can include average rooms. If you want to include, you can include house age, and maybe negative correlation also you can include, because negative is also affecting the target variable. That means these are the features which are trying to increase the median house value, but these are the features which are trying to decrease the median house value, right? Okay, now this chi-square test. So chi-square test, here we want to do the same data. So that is why I said that same steps of these steps that I will not show again and again. In fact, I just copy this cell and paste below cell below, and then I just move it above the chi-square test, so that you will know that we are doing the same steps again. So that are already done, and now we are x train, x test is already created, and x train scaled is also created, and x test scaled is also created. Now for chi-square test, we are binning our x train and our y train. What is our x train? If I just want to show the output, then I can show you the output of x train, y train by this much, these lines of code, right? So this is uppermost is my X train feature matrix for the training data. This is my Y train target vector for the training data. This is my X test feature matrix for the test data, and this is my Y test target vector for the test data. So I have shown this, and this. Hope things are clear. Okay, and then I just have to import chi-square test and another feature selection, select k-based, that we have already used earlier. Select k-based, but this time I am using chi-square test for selection, right? So we are binning the features. So X train at present is like in this form, but we will convert it into some bins. Say all house whose value fall from 1 to 1.5, they will be one bin. Then 1.5 to 2, that will be another bin, and so on, right? Because chi-square test is performed over groups or categorical variable and non-numeric, not on numerical variables. So these are at present all numerical variables, and therefore you have to bin all of them. So we bin them and use the chi-square test. Input X must be non-negative. Where is the negative input? I think there is no negative input here. Just a minute. Yes, here actually that latitude was negative. If I see earlier, longitude, sorry, and that was creating the trouble, right? So I did one such small step earlier, that I just dropped the longitude column, because chi-square test showed me that error, that negative values are not allowed here in this binning process. So now I think no error should be there. Still some error is there, that is median house value, and now this time the error is input access still must be non-negative. So maybe I have to drop even the latitude also, but there is no negative value seen here. Okay. Yes, so I had to change the code because we did some mistake, that we chi-square. I said in the earlier part of the lecture that chi-square test is only for categorical variable, and therefore we did binning of x, but we did not do binning of y, and therefore it was creating trouble, right? So just like x is binned, similarly y also, y trained bin and y test binned should be required, because otherwise all the columns are integers here. So integer columns and chi-square test do not go together, right? So therefore we had to bin and convert it into categorical variable, and then if I execute this code, forget about the code at present, we have done chi-square test, a lot of discussion, but last part is important, that is using chi2 selector, which object which you have created here, somewhere you have created that import chi2 selector. Okay, so then chi2 selector is equal to select k boost, and use score function chi-square and select 5 best features. So out of these 8 features, this you are asked this and that one more, yeah, only not 8, because we have dropped longitude and latitude. So in that case, maybe why drop, I can keep it. Okay, so let me remove this. Perhaps that would not throw error, or perhaps it might throw, because that latitude and longitude have some negative values, so it might throw error. Let us see. No, it does not throw error. Okay, fine. So that is what you are selecting all your features. Okay, and I will do from earlier. This is my x and y. These are my x train and y train. Printing x train, y train, x test, y test, so that latitude, longitude are present. Yes. Now this longitude having negative value might create some trouble, so that's why I removed them. But let us at present keep it. I have commented out that line which removed latitude, longitude, and I'm trying to perform chi-square test. No, it does not throw error. That is good. Okay, and you can see that there are 9 features. This 8 features. These 4 and these 3, and then this longitude also. But I asked my chi-square test that select k based using score function chi-square, and k is equal to 5, and it gave me this result, that median income, its chi-square is highest with the response variable. Response variable is my median house value. So median income is the highest related with median house value. House age is also related weekly, but related with average rooms is also related, average bedrooms is also related, and population is also related, and average occupancy is also related. So if you want to find top 5 features, then you can take these 5 features, okay, and p value for all is coming out to be less than 0. I mean less than significance level 0.05 or 0.025, whatever you want to take. But that shows that this decision that median income is related highly with the response variable, that is median house value, that is fairly confident. That is, we can confidently say that null hypothesis is rejected. Otherwise, null hypothesis would say always that median house value is not related with median income, but we could reject the null hypothesis. Similarly here also, and all these cases. So these are important features. Okay, what is the interpretation of this? Then higher chi-square indicates stronger association between feature and the target variable. Then median income has the highest chi-square, meaning that it is the strongest relationship with the target variable, and average bedroom has the lowest chi-square. So average bedroom, of course, here I have taken 5. So population is having no, average bedroom is having the lowest chi-square, only 20, right? So suggesting weak association with the target, right? That is one thing. P value is coming out to be 0. So null hypothesis says that there is no relation between y, target variable, and all these features, but that null hypothesis is rejected, okay, because p is less than 0.05. And selected features. Now selected features are these top 5 features, and you can, instead of creating your model based on all 8 features, you can create your model based on only this top 5 features, okay, whatever top 5 you found in this case, okay. And what is practical implication? Median income is highest correlation with the house value. That is expected because in areas where high median income will be there, people will buy bigger houses, costlier houses. They will maybe make, instead of 2-floor bungalow, they will make 3-floor bungalow. So obviously the house price will be higher. House age. Now it seems that older houses are more costlier, because earlier also I discussed that older houses are means that when that area was developing at that time, the house was built, but now that area has a fully developed neighborhood and it is now posh area. So that is why median house income is more. Average rooms per dwelling, obviously bigger, more number of rooms means bigger house. And population is affecting, that is also something to do with established neighborhood, and that means that it is also positively affecting. More population also means more infrastructure, more demand for businesses, and better infrastructure. And average occupancy per household, this is affected. This affects the median house value, but not much. You can see that its chi-square is only 50, so that is okay, but it affects. Now instead of top 5, I just make this top 3. Someone says select top 3 features only, then everything remains same, but you just have to select top 3 features, and now median income, average room, and population, these are top 3 features, right? So that is very simple way of doing analysis, though this data set was not particularly suitable for doing analysis by chi-square test, because all columns are numerical, and when you do binning and etc., you are actually disturbing the original nature of the data set, which is often not preferred, right? So okay, as for the sake of demonstration I have shown. Otherwise you can use other methods. For example, earlier we have done select k best, okay, and then we have done here in the wrapper filter based method only, we have done one earlier method, that was this method, that is correlation based feature selection, right? So you can use the most correlated feature, and you can find the features. It's still one more filter based method is there, and that also you can use, which is mutual information based feature selection method. At present we are doing all filter methods, and therefore we are at present doing statistical methods. So certain scores are created, and those scores will decide which features have highest correlation, or highest rather predictive power for a given this prediction, okay, that is given response variable. So response variable in my case is median house value, so I want to find which feature has the highest predictive power. These many steps are always common, that you create your data and create X test and Y test. We have already done them, so let us execute. Next, okay, here again it is shown, no, this is that, okay, mutual information. So from sklearn.feature selection, import mutual underscore info underscore regression, and then create mutual information scoring object with X train and Y train. So you are training your algorithm, and you are calculating something called MI score, mutual information score, okay, and that MI score, then you are even plotting one diagram of mutual information score versus feature, okay, a sort of bar plot. So it will readily show which feature has the highest mutual information score, and then you can select top 5 features. here head 5 is written, so top 5 will be selected. You can select instead of that head 3, so top 3 will be selected, and so on. So this is again throwing some error. All arrays must be of same length. Okay, let us see what is the issue. Okay, I think the problem was because we dropped that X train and Y train earlier only, somewhere here, here. Okay, X train and Y train were dropped, and again we are dropping. Perhaps we were dropping. I just now commented this line. So if you comment out that line and execute, then you will see this kind of feature importance plot or mutual information plot, and you get this kind of plot based on which also you get that the most important 5 features are median income, average rooms, average occupancy, house age, population, and last is this, but most important 5 are to be taken, so you don't take the last one, right? So median income, average rooms, average occupancy, house age, and population. Top 5 bars. The longer the bar, more is the mutual information scope. Okay, and that you can compare with what you got with this chi-square test, right? So there also, of course, there I took later on k is equal to 3, only 3 features. Let me again make it 5 features. So median income, house age, average rooms and population, and average occupancy. Median income, average rooms, average occupancy, house age, and population. Same 5 features are obtained. So this is about the mutual information based filter method. Okay, and you can see that sometimes it may throw a little bit of here and there error, so you might have to debug, and sometimes just a silly mistake is found that you have to resolve. Okay, now based on this, this lecture is over at this point, and we will do in next lecture the wrapper based method, because in wrapper based method also we have done only one, but actually speaking there are 4 wrapper based methods, right? So where are they? Then here, this wrapper based method, RFE, forward feature selection, and backward feature elimination. 3 are there. So we had done only recursive feature elimination, and this we kept. Similarly, here we had done only k based feature. So these 3 were left that we have just now done: correlation based, chi-square based, and mutual information based. But k based features is always the nicest method among filter method. Okay, then recursive feature elimination, the first one whichever was done, that is the nicest method for wrapper method. While here, okay, the lasso we did, that is not necessarily the nicest, because the RF or XGBoost can be better method. In general, embedded methods are always better, but currently we want to do this forward feature selection and backward feature elimination. So our next lecture will handle wrapper methods, but among which RFE is already done. So these 2, right? Okay, thank you, and we'll see in next lecture.